Windows function. What are the Windows functions? What are their uses? And we'll look into some of the examples and also some of the popular Windows functions that are in use in day-to-day life. So a window function is by definition is a function which uses values from one or more rows to return a value from each row. This contrasts with the aggregate function which returns a single value from multiple rows. So windows and functions have over clause. Any function that doesn't have the over clause is not a window function, rather an aggregate or a single row function, such as the sum without over clause. Some of the common Windows functions are sum over, which is used for computing running totals, average over, computing for moving average, rank over, so rank item within the order patterns or group. If the rows are assigned the same rank, it will skip the count for the next rank. Whereas dense rank is also an over, which is also similar to ranking. It gives consecutive ranking for order patterns. It does not skip ranking, so the ranking will be continuous. In case of the rank, the ranking will be skipped. So row number over gives number of rows, and entile over breaks a table into a specific number of approximately equal groups or buckets. Lead over or lag over accesses values ahead of the row with the lead or before the row with the lag. How many items to lead or lag is specified in the lead lag clause. So in terms of the uses, Windows functions are used to aggregate values and find patterns in datasets with the lead and lag. Also find the statistics of the table. Let's move ahead and look at the syntax. So in terms of the syntax, Windows function, normally you have select and then columns, and your aggregate functions such as sum, average, and so on, an over clause within which you could have like partition by and the columns and order by the columns. So the name partition by refers to as partitioning into buckets, and order by orders the those values within the buckets and overall, and you have at the end from the table name specification. So whenever you have sum over, average over, you have the Windows function. So let's look at one example of the sum average on product. So over here we have select product ID, name, unit price. So we are summing the unit price over as total unit price. So in this case, inside the over statement, we didn't put any partition by and order by. So which basically means that it will get the total sum of the unit price. So all the items and what are their total sums, and then make it separate column as total unit price from product. And in the next examples, in order to do average, we just place average in the place of the sum, similar to select product ID, name, unit price, and average unit price over as average and then price from product. Another example is rank over on a category name. So if you want to rank on a category name, we have select product ID, name, unit price, category name, and then we have a rank keyword and over. And inside the over, in this case, we have partition by category name, order by unit price, and then as a rank item, and from product, order by category name. In order to use entile over on product, we do a select entile, and in this case 4, means dividing into 4 partition over as grouped item, category name, product ID, name from product. For the lead lag, we need to get the previous and the next items from the table of the customer. So we do select lag and a first name. We are getting the first name one step before with the one, and over order by first name, and we say previous F first name or F name as first name, and then we get the first name, and then lead first name one over order by first name and the next first name. Okay, from customer order by first name. So let's look at hands-on. We will open up our PC admin and go through this code and look at some of the outputs as well. So let's open up our PC admin. First thing first, let's look at the products table. So we'll just do select asterisk from product, run this query. And sure enough, we can see over here we have product ID, name, unit price, and then category name. As you can see, the three items in a fruit category, four items in the vegetable category, and another three items in the groceries category, which is like mango juice, milk, and bread. And then the mango, orange, and apple are in the fruit category. So this information is important because later on we will be referencing this table for our results. So let's go ahead and write our first Windows function using the sum and over. Now let's go ahead and run this query. So once we run it, as we can see, we get the product ID, name, unit price, and total unit price, which means the sum of all the unit prices over here. So which is 25.2 in this case. So this information might be useful if you want to do how much unit price deviates from the total product prices that we have, or some analytics that you want to do. So if you want to get the sum categorized or partitioned by buckets into the category name, we can also do partition here. I can partition by category name underscore name. And in the previous example, we saw that there were three categories. So let me pull up this one. So over here, so this in this product table example, so the fruit has three items, so it will just do a sum of 1.3 and 2.3 in this case. So 3.6 and then plus 2, which is like 5.6 for the fruit, and so on for the vegetable, and so on for the groceries. Let's go ahead and run this query. Yeah, sure enough, the for the all the fruit, the three items, we have the total unit price. So we probably want to write this as a total unit price per category. And then we have 5.6 for the other categories, 11.5, and the for non groceries it's 8.1. Likewise, in order to get the average over here, and then if you want to get the total average, we remove this one and run this query. And then sure enough, we have the average unit price. So we can also write this as total average. A, a average price, and run it again. Is 2.5 is the total average, which means that sum of all these divided by the total number, in this case 10. So previously it was 25.2, the sum divided by 10 is 2.5. So now if you want to do per category as done previously, we can also partition by category name. Name. So now in this case, we get the 1.86 for the fruits category. The value we are getting over here is 2.3, 1.3 plus 2 divided by 3. So the average would be that, and which equals to 1.8 something. So which is shown by this one, and same for the vegetables and the groceries. And the 3.8 and 2.025. Let's move ahead with the next example of rank over, and then we can also see dense rank over in this, and entile and lead and lag. So for the rank over, name, and we want to do a rank over here, but first we want to get it from the products table. So I will just write product, and we want to order by category name, and then we write our Windows function, which is rank and then over. And then in this case, we want to partition. partition by. We want to do partition as this is as a rank item. And for the dense rank also we can see dense rank, and then the same clause would be applied. Oh, and then let's go ahead and then okay, let's go ahead and run this. We'll indent this first and try to run this. And over here we can see that the it is ranked by category. So for the fruit is 1, 2, and 3, and the dense rank is also the same. And over here for the groceries 1, 2, and 3, and for the vegetables also 1, 2, 3, and 4, and the dense rank is also the same. So in this case we are not skipping any values. So if we were to skip any values, then the dense rank will be continuous, whereas the rank will not be continuous. It will start by skipping a value. So for n-tile example, we can see uh, see from the product table, select, and once select from here the product table, and we will select the n-tile information, and we will group as n-tile with 4 partition, and then over as group item. Now, and the name. Now let's run this query. And sure enough, so the n-tile has grouped items based on the partition that we have given, in this case 4. So this is like first group, second group, third group, and the fourth group. Now let's look at the another example of lead and lag. So for the lead and lag, we'll just be getting first name from the customer, and we'll also give the previous first name and the next first name. So using the lag we get the previous first name, using the lead we'll get the next first name. So we'll do select, and we want to select from customer, and we also want to order by first name, because now for the lag information we do lag, and which column do we want to apply to this? In this case is first name. Over here also we can see the first name in the okay, in the customers tables, and with the lag you can specify how many steps you want to go back. So for this case we just want to go back 1 step, so the previous name, so we'll just put 1. If it to 2, it will skip to the second the previous name, and so on. Over, and in the over clause we will just be using order by first name. We will not use partition by, and we will just be calling it as previous f name. So if you want to have like space in your naming, you have to surround it using a quote, and then we will have first name, and then we have a lead, next first name. Now let's go ahead and run this query, and sure enough, so So for this is our first name in the customer table. So we are ordering by the first name, and over here for Anita there is no previous name. Then we the next name is Brittany, and for Brittany we it came down. The previous name was Anita, and the next name was George, and then we come to George. The previous name was Brittany. The next name is Henry. Then we come to Henry, and so on. Sure enough, so our lead and lag function works. So in this section, we saw Windows function. In the next section, we'll be seeing triggers.